9.7 notes. Yesterday we talked about solving a quadratic equation by factoring, getting the two solutions that would be the two x-intercepts. Today we're going to learn a second method. The second method is the square root method. We'll learn the third method later. In the square root method, it is possible to solve for x when it is being squared by taking the square root of both sides of an equation. Please note that you can only use the square root method if it looks like ax squared plus c. There is no b term. There is no other x, and the only x in the equation is the x that is being squared. To talk about why this works, I want to quickly review a chart that we made together in Chapter 7. Do you remember this chart when we were doing our exponents? And we talked about numbers when they are squared. Now notice that 4 happens when I square both 2 and -2. Likewise, 81 happens when I square both 9 and -9. For that reason, square roots actually have two answers. The square root of 36 could both be 6 and -6. Square root of 121 could be plus or minus 11. Square root of 4/25 could be plus or minus 2/5. Square root of 4 is 2, square root of 25 is 5. And the square root of 6/25 would be plus or minus 25. Even if the negative is out front, it is plus or minus, but the minus would change the plus to negative, and the negative would change the negative to plus or minus 25. Let's work through a few examples to see how this works. First example, x squared equals 64. Take the square root of both sides, and x would equal plus or minus 8. You can use your calculator, or you can use the chart, noting that the square root of 64 could be either positive 8 or negative 8. On a graph, this would be a parabola opening upward with zeros at -8 and +8. Looking at the next example, we see that x squared equals -4. A positive squared number cannot equal a negative number. This would be no solution, and the way that this graph would look would be some sort of an opening up parabola where it does not cross the x-axis. We'll learn more specifically how to graph that later. Looking at the third example, the square root of both x would equal 0. Notice that this would only have one solution, or one x-intercept, and it would happen right at x equals 0. Again, that parabola would be opening upward because a equals 1. On this next example, we need to solve to get x squared alone first. We have x squared equals 49. Then we could take the square root of both sides, noting that x could equal positive 7 or negative 7. On a graph, it would go through -7 or 7 as our x-intercepts are zeros, again opening upward because a is positive, and our parabola would look like that. Looking at this next example, I would add 25 to both sides. I would get 4x squared equals 25. Divide both sides by 4. X squared would equal 25 over 4. Taking the square root of both sides, x would equal the square root of 25 is 5. The square root of 4 is 2, plus or minus 5/2. Making our parabola have zeros at -5/2 and +5/2. This example looks a little bit different. The quantity being squared is x plus 2. We can take the square root of this entire side and the square root of this side. The square root and the squared cancel, leaving me with x plus 2 equals plus or minus 3. At this point, I need to break my problem into two pieces and say x plus 2 can either equal 3 or x plus 2 can equal -3. Subtracting 2 from both sides, x could equal 1. Subtracting 2 from both sides, x could equal -5. My parabola would have x-intercepts or zeros at 1 and at -5. Again, it would be opening upward because my a term is positive. On this example, I would start by subtracting 49 from both sides, trying to get my x term alone. I'd get 100x squared equals negative 49. Divide by 100. X squared equals negative 49 over 100. Whoop, hold up. We can't have a positive x squared be equal to a negative number. Let's say that I said it could equal 7 over 10, the square root of 49 over 100. Well, if I square 7, I'm going to get positive 49, not negative. So there's no way to square a number and have it equal a negative number. For that reason, there is actually no solution to this. We'd say no solution. There is no value for x that would make this true. And on a graph, our parabola would look something like this. Without any x-intercepts, that parabola would not cross that x line at all. On this example, my squared term is already by itself. Taking the square root of both sides would leave me with x minus 5 equals plus or minus 4, in which case I have either x minus 5 equals positive 4 or x minus 5 equals negative 4. Adding 5 to both sides, x would equal 9. Adding 5 to both sides, x would equal 1. The zeros on my parabola would be at 1, 2, 3, 4, 5, 6, 7, 8, 9, and 9. Again, my parabola would be opening upward because a is positive. And these are the two solutions or values that make this equation true. On this example, I would start by adding x squared to both sides. I want to get my x squared term alone. Notice that at this point, 90 is not a perfect square. If I take the square root of both sides, I would get x equals plus or minus a decimal. It is also possible to write this in a different way. It could be, because 90 is equal to 9 times 10, I could write this as the square root of 9 times 10. The square root of 9 is 3. So you might see your answer written as x equals plus or minus 3 times the square root of 10. You could also see this written as an approximation of 9.5. If you plug square root of 90 into your calculator, you could get plus or minus 9.5. Both of these answers would be all right. Notice that this parabola would be opening down because the a value on our x squared is negative. On this example, I would start by adding 64 to both sides to get my x squared term alone. 2x squared would equal 64. Divide both sides by 2. X squared would equal 32. Taking the square root of both sides, x would equal plus or minus the square root of 32. Because 32 can be written as the product of a perfect square, 16 and 2, this could be also written as plus or minus 4 square root of 2. It could also be written as approximately plus or minus 3.7. If you take the square root of 32 and put it into your calculator, it's approximately 3.7. Either of these answers would be all right. On this next example, we notice that when we try to isolate our x squared term, we get a negative number. Remember, a squared x cannot equal a negative number, so this would be no solution. On this example, when we try to get our x squared term alone, we start by subtracting 90 from both sides. Then we divide both sides by negative 3. And we get x squared would be equal to 30. Taking the square root of both sides, x would equal plus or minus the square root of 30, which is not a perfect square, and there are no perfect squares that divide evenly into 30. So you can either leave it as plus or minus the square root of 30, or you can approximate it on your calculator as plus or minus 5.5. Our last example is a word problem about a zookeeper, and he's buying a fence that is an isosceles right triangle to enclose a pen at the zoo. There's already a fence on this side by the path, so he's going to need fencing here, distance x, and fencing here, distance x. And we want to know how many feet of fencing he should buy. The area of the pen will be 4,500 square feet, the area in here. Well, to take a look at this problem, if you remember, area of a triangle is 1/2 base times height. The base in this case would be x, and the height in this case would be also x. And we were told that the area of the pen is 4,500 square feet. To solve this, we notice that it is a quadratic equation because it does have an x squared. X times x is x squared. I'm going to start by isolating my x squared by multiplying both sides by 2 to get rid of this 1/2. In that case, I would have 9,000 equal to x squared. Can take the square root of both sides, would be about 98.9 equal to x. Now, technically, it could be plus or minus 98.9. That would make this original equation true when we plugged in 98.9 for x. However, you cannot have a negative distance or a negative length for x. So our final answer will be x equals about 98.9 feet for each side of that isosceles triangle. And let's change it to approximately because we rounded.